The University of Rhode Island Energetics Lab has been studying explosives for many years. As a part of ALERT, we have been looking into many of the issues faced by first responders and the threats that they may encounter in the field. One of the first problems that we have tackled are how to train bomb dogs to be able to detect vapors of dangerous explosives without the hazard associated with pure material. Not just military explosives like TNT and RDX, but homemade primary peroxide explosives such as TATP and HMTD. To make them safer, we have encapsulated these materials in a polymer that allows for on-demand release of pure vapor without requiring bulk explosive material. The addition of the polymer coating did not result in change to the vapor signature of the explosive, but the explosive was less sensitive to initiation as seen in the photo. We partnered with a company, Detecticam, to design a heater that could safely release the explosive from the polymer to be used for training, either with dogs or detection equipment. To address some of the problems that currently plague ion mobility spectrometry, particularly in the analysis of non-volatile threats, we have been developing a new ionization source that we have named Ambient Desorption Ionization, or ADDI for short. The ADDI has been designed to attach to existing IMSs. In our lab, we are currently using an XLM IMS. However, we are speaking with other IMS manufacturers at the moment. ADDI uses the voltage source already present from the IMS, so no additional power will be required. ADDI is also compatible with current swab technology, though swab geometry is modified. It also requires a small amount of solvent for swabs. Current volumes of solvent are in the 10 microliter range. The operation of ADDI is simple. A small amount of solvent is placed on a swab and introduced into the IMS. In its current configuration, our IMS is connected to an exact mass spectrometer, allowing for identification and assignment of peaks seen in the IMS. The voltage supplied directly by the IMS is enough for the ADDI to ionize the sample, allowing for identification of non-volatile inorganic substances. For example, ADDI IMS is capable of ionizing and separating 3 non-volatile threats, nitrates, chlorates, and perchlorates, into individual peaks based on drift time. This, however, provides no structural information. To determine which peak represents which compound, we must first isolate and gate them individually into a mass spectrometer for accurate mass identification. Once the drift times are assigned for each compound, the libraries can be built for a standalone ADDI IMS device. While we have focused on the analysis of non-volatile compounds that are traditionally difficult to analyze by IMS, organic compounds work just as well. Analysis of TNT, RDX, and PETN shows that there is good ionization under ADDI conditions. Switching between the native source and ADDI is simple. No tools are required to swap sources. Though still developing, our new ambient desorption ionization, or ADDI source, has shown promise for the analysis of illicit substances. The ability to measure both traditional organics by ADDI IMS as well as inorganics increases the scope for the use of IMSs at airports and other security checkpoints. For further information on ADDI, please contact us. First responders can encounter a number of various threats in the field, making it difficult to predict what one may face on a daily basis. With the threat of explosives, narcotics, and even chemical warfare agents, there is a need for plans once such a threat is encountered. We have developed a product to help in such scenarios.
SCHMOO, or Safe Control of Hazardous Materials or Others on Site, is our solution to first responders finding explosives, contact hazards, chemical warfare agents, or other unknown, potentially hazardous materials in the field. Current disposal techniques mainly involve controlled burns, EOD disposal on site with suits or a robot, or having entire hazmat crews show up for disposal of those materials. The targeted users of this would be bomb squads, hazmat, military, law enforcement, or other types of first responders. SCHMOO is comprised of two parts. Part 1, which is first applied to your target material in order to desensitize or render safe, and then Part 2, which solidifies Part 1 to allow for easy removal and cleanup. Part 1 comes in multiple different form factors. It has a either concentrate gel pack, which can be diluted down, a concentrated version, which in this case is shown in a syringe, and then a ready-to-use syringe or bag that can be deployed on hand. To use SCHMOO on a given threat material, such as TATP or fentanyl, first apply Part 1. This would be in either a gel pack or syringe form. Once the material is isolated and covered, it is now safe to manipulate and maneuver. If it's an explosive, it is desensitized to impact, friction, and ESD, which we'll go over a bit later. If it is an air material you're worried about getting thrown into the air because it's too powdery, such as fentanyl, it is now covered and should be much less likely to go up in a poof. Once you're settled with how much you applied for Part 1, you then spray on Part 2. Within seconds, the material will begin to solidify inside of the SCHMOO Part 1 matrix. Once that's done, you can easily pick it up for removal or for transport. SCHMOO does not interact with chemicals or with most organic molecules, therefore making it inert and keeping your evidence safe for forensic use later. Now we'll show you a demonstration of what happens when you introduce SCHMOO to fire and to impact.
Fire in the hole! 3, 2, 1. Basically, open up our packet, apply that to our threat material, make sure to cover it nice and good.
Can you work so that you're...
Yeah.
Thank you.
Yeah, get that all in on there, and then we can come back, manipulate it, get it all well dispersed so that way it's well mixed. You don't need to do this, but it helps. It makes the process a bit better and easier to remove. And then once you have it done to the degree you like, you just come in with your sprayer, and then now it's solidified. You can pick it up, walk away with chunks of it that are manageable, and then let's say one of your guys gets a little too loose with his feet.
Let me zoom out. Yep. And I still don't trust everything.
Yeah, it's gonna spray. So just all right. Fire in the hole. 3, 2, 1. And you might make a slight mess with your SCHMOO and material spraying everywhere, but at least you're not going to set it off anymore. Yeah, ideally you don't hit it with a hammer.
Specifically, when investigating explosives and the effect SCHMOO has on it, we looked at impact, friction, and electrostatic discharge sensitivity. This is the typical things that a potential primary explosive may be insulted to. To start with impact, this is where we're measuring how much force or how much energy it takes from a given weight when falling on the sample to initiate it. As you can see with TATP, the impact sensitivity was unable to be measured on our instrument because once we added SCHMOO, it was so insensitive that our highest or greatest amount of energy would not initiate it. In terms of friction sensitivity, we saw orders of magnitude decrease in friction sensitivity. This is done by essentially dragging a ceramic pin across a plate and measuring how much force that it takes to initiate the explosive. In this case, we went from 0.39 newtons to 59.8, over 100-fold increase in the safety of the material to friction. With electrostatic discharge, we introduce a controlled amount of electricity to our sample in order to see how it responds to a spark. In this case, we were able to observe an order of magnitude reduction in sensitivity to electric discharge with SCHMOO. In addition to reduced sensitivity, once SCHMOO is applied to a hazardous material, it also renders it safe to open flame.
Fire in the hole. 3, 2, 1.
Okay. In summary, we've developed a way to desensitize materials such as explosives, chemical warfare agents, and other dangerous materials to impact, friction, and electrostatic discharge, in addition to fire. We've also figured out a way to make sure that the material stays confined from first responders in the case of their interaction with it. SCHMOO will also increase the safety of removal, transport, and storage of these hazardous materials, and is a non-destructive technique that allows for future forensic analysis if needed.